So here's a function with four arguments: a, b, c, and d. So a has no default value. B, c, and d all have default values. And so when you define a function, you to both specify the names of the arguments and whether or not any of the arguments have default values. So null is a common argument, common value to assign to an argument, which can mean a variety of things, but it usually means that there's nothing there. So one of the key features of the R language is what's called lazy evaluation. So lazy evaluation is a common model in a variety of programming languages. And the way that it works is that all the arguments to a function are only evaluated as they're needed. And so, for example, if you take a look at this function over here, you can see it takes two arguments, a and b. But the body of the argument only does one thing. It takes a and it squares it and then returns it. Now recall that in a function, the return value is whatever the last expression is that's evaluated. So there's only one expression in this function, so that's the last expression. And so it's the return value. So if I say f of 2, what happens? Well, in R, what happens is you get 4 because 2 squared is 4. Now you might be wondering, well, what happens to b? When I call f, I never specify what the value of b is, and furthermore, b doesn't have a default value, and so what happens? Well, what happens is nothing happens, because the function f doesn't actually use b, and so the argument is never evaluated, and so because it's never evaluated, there's really no error, there's nothing that's going wrong here. Now you might say that, of course, well, the function f is kind of poorly defined, so why would you give an argument where that's never actually evaluated? And that's a reasonable objection. But in this case, the function will operate correctly because the value of 2 is positionally matched to the argument a, which is then squared. Here's another example of a function that's only slightly more complicated than the previous one. So this is another function that takes arguments a and b, but now what the function does is it prints out a and it prints out b. And so when I call f of 45, look what happens. I get an error that says in print b, argument b is missing. So here, what happened is that it printed out 45 because 45 was matched to the argument a. And so there was no error. Up until the first line of the function, there was no error occurring. But then when it got to the second line, it had to evaluate the argument b. And because b had no value assigned to it and no default value, then an error had to occur. So here, but you notice that the error only occurs after the 45 was printed out, and so the lazy evaluation implies that because the argument is only evaluated when it's needed, everything else that comes before it, if that's valid, then it will execute until it hits the part which causes an error. So there's a special argument in R functions, which is the ... argument, and it's used to indicate a variable number of arguments that can sometimes be passed on to other functions. So the 3 dots are often used when extending another function, and you don't want to copy the entire argument list of the original function. So for example, you might want to extend the plot function, and just to have a little bit of a tweak or to change some of the defaults, for example. And so for example, you might create a function that's called myPlot, and the myPlot will replicate some of the arguments of the original plot function, like x and y, but it's going to change the default type argument so that instead of creating circles for points, you want it to create lines. So you say type equal to L. But of course, the default plot function has many other arguments, and you want to leave them all to be the same. And so what you can do is you can pass ... and then that can be used to kind of absorb all of the other arguments in the plot function. And then what happens is I'll take the ... and then pass it down to the original plot function. And so all those original arguments can be preserved, and I don't have to retype or reconstruct all of those arguments in my extended function. There's another use of the ... argument, and it's for what are called generic functions, so that extra arguments can be passed in methods. So we'll talk a lot about more of this later when we talk about object-oriented programming. But the basic idea is that in R there can be special functions called generic functions which don't do anything, but what they do is they dispatch methods for different types of data. And so the ... is used very heavily in this type of setup. So lastly, the dot 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 argument is necessary when the number of arguments that are passed to a function cannot be known in advance. So one good example of this usage is in the paste function. So the paste function, what it does is it concatenates a set of strings together to create one string or a vector of strings, and it can take a variable number of arguments. So there's no way for the function to know in advance how many arguments it's going to have to paste together. And so the first argument for paste is actually dot dot dot, and therefore you can take a number of different R objects that are character vectors and then paste them together using a separator and which in case the default is the space. So there are other arguments to paste, which are sep and collapse, but they come after the dot 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 argument. Another function that has dot 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 as the first argument is cat, and what cat does, similar to paste, it pastes together a number of strings, but then it prints out the concatenated string either to a file or to the console. And so you can see there are many other arguments to cat, but the first argument is going to be the set of R objects that are going to be concatenated. So the one catch with the dot 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 argument is that any arguments that appear after the three dots on the argument list must be named explicitly, and furthermore cannot be partially matched. So you can't use positional matching or partial matching for arguments that come after the three dots. And this kind of makes sense because otherwise there's no way for R to know whether you're passing something to the dot 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 or whether you're passing something to a different argument. So if I say in this first example here, if I try to paste together A and B, so A and B are going into the dot 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 argument, and then I say sep equals colon, which means that I want to paste them together by separating them into with a colon. However, if I try to do partial matching with sep, what happens is that the partial matching gets ignored, and so when I say paste A, B, and then SE equal to colon, well, the SE is in another circumstance might be partially matched, but in the paste function it can't use partial matching, so it just ignores that and just assumes that colon is just another string to be pasted together, and so then you get the string AB colon. So just be careful when you're using functions that have dot 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 as an argument, that any arguments that appear after the three dots have to be named explicitly and in full.